Hello, everyone. Hope you are all well and healthy. It's a pleasure to be here on Warsaw.js stage again, even if virtually this time. And today I'm going to tell you a story on how online tracking looks like and what you can do about it. A story that may get a little scary, but also the story that showcases how we can use our skills to improve the web. A story of tracking the trackers. So I hope you will enjoy it. So let us begin. So the web is driven by standards. You probably know W3C that creates specification for HTML and CSS, and about TC39 that builds the JavaScript specs. Those standard bodies are doing an amazing job of building consensus of how the web should work. This creates an unique environment of constant innovation under control. When we have the consensus, specifications are produced, then browser vendors have to implement them and release in a fixed release schedule. But it all takes time. Most of the modern browsers release a new version every month or every 4 weeks. With all that, browsers create a platform that is not bound to a fixed release cycle. Websites can update whenever they like, providing content and tools we use every day. Web extensions can add features to browsers which otherwise would not exist, as browser vendors would not have time being busy running the infrastructure. But there are also other parties involved, and I will get to them in a moment. Let's talk about web extensions first. Did you know that Firefox invented extensions in 2002? This was like version 0.2. They were one of the reasons behind Firefox's massive success. And when Chrome was starting in 2008, they had no other choice but to start with an extension system as well. Otherwise, many users would simply not be able to switch. They were just too accustomed to the customizations that the Firefox was providing. And today, we are witnessing another generation of the browser wars. This time, it's not about whose engine is fastest or passes more compatibility tests. It's all about features. Today's contenders to the browser wars come with many of popular extension features baked in. This is great as browser vendors acknowledge the value of web extensions ecosystem that is provided. And the value is huge. We are so used to be able to choose our password manager, content blocker, new tab page, or a search engine. Web extensions turn a browser into an operating system that can innovate fast. But you know what else innovate fast? Surveillance advertising. What's that, you ask? Well, let's take a close look on the state of the web. Nowadays, virtually every website comes with dozens of third-party scripts loaded. Some of those are included intentionally by publishers. Others are fetched in runtime by the ad tech. The moment you visit a website, trackers will start gather information about your behavior and share it via ad exchange with even more trackers. Here we see one ad script downloading a bunch of others. And what they do, they gather information about our browsing activity and exchange it between each other, building a complete profile of our behavior. You may think it's okay as they are only interested in your shopping history or maybe search queries. But let's take a deep dive into what trackers actually see. This is a URL log. I hope you can see it fairly well. This is a list of pages visited by a single user. There is no user ID here. As ad tech says, anonymous identifiers are used instead of your identity. So tell me, is such list truly anonymous? Well, This data set comes from a single user. It has around 7,000 entries and spans for about 2 months of regular browsing. At first, we see only searches on Google and Amazon Shopping. Looks safe, doesn't it? I've spent around 40 minutes analyzing this dataset by hand. Was quickly able to group some of the URLs together to learn a few facts about this anonymous user. So what we can learn here? First, the person is definitely a student at Harvard, as he has, and we know which classes he or she is attending. We know that's the fact for sure because we can see the private URLs which are only available to students and to graduates. Next, we can tell what's the professional social network of this person look like, because we see a lot of LinkedIn URLs, which I here do not disclose to protect the people behind those profiles. But we saw quite a few of those. Next, looking by the general URLs, we can quickly scan the interests of this particular person. Judging by the URL, we can definitely tell this person is very much into politics of Saudi Arabia, and most specifically into the petrochemical industry. Judging by the Google Maps URLs, we more or less know in which city and street the person lives. And judging by the booking.com, we know in which hotel she stayed when on her business trip to Cambridge. But it gets even more interesting. We can quickly identify that this person is a MacBook Pro user and has an iPhone. By the way, she's also using Firefox because she's looking for some add-ons. And here's something scary starts. This person tries to self-diagnose for a very specific issue and looks for drugs online. I will not disclose those parts of URLs, as this information is really specific and would easily allow us to de-anonymize this dataset. Next, the work. We see the person works in Saudi Arabia government and has access to private resources of those organizations. And likely is looking for a position in a similar job in Qatar. And then we learn about a distinct taste in porn this person has. Actually, now I think that's a guy. There was lots of porn URLs in this blog, in this URL log, believe me. Last but not least, we are able to get user ID of Oxford Business Group and Harvard as well. And in the Google Docs that are not disclosed here, we were able to find names and email addresses of this person and a dozen of their colleagues at Harvard. You can clearly see URL logs are nothing but anonymous. You don't need a user identifier, just acknowledge that such set belongs to a single person. So what can we do about this? Because this is scary. Publishers won't help us, as they are in trap of surveillance capitalism. Some browsers, like Firefox and Safari, do some good work to limit the tracking. What about Chrome? Well, Google earns money from ads, so Chrome stays neutral. Fortunately, there are web extensions that can help. Ad blockers and tracking protection tools utilize the power of web extension platform to protect our privacy. Let's implement a content blocker together. Everything in web extension starts with a manifest.json. This JSON file describes what web extension is allowed to do. In this case, we want to block content, so we need an API called web request. We add it to the permission list. We also added this HTTP wildcard to have wide access to all hosts in the browser. This will allow us to get the information about every website. We also have to define a background script, which is a place to run our code. it looks more or less like this. To illustrate the power of Web Request API, we can make web a bit cleaner by removing all images. So this snippet adds a listener to Web Request, which fires every time a browser wants to load an image, and then it stops the request. In result, that's how CNN.com looks like without images. It's a bit lighter, don't you say? That's a certainly noticeable change, right? But we want to web a bit more private, not exactly removed from images. So first, we need to know what to block. Fortunately, there are communities like EasyList that maintain lists of URL patterns that identify ads, trackers, and other annoyances. These lists are huge. They include tens of thousands of block requests. Sorry, block rules. Let's say we have a list of URLs to block, a block list. What we can do is to check every request in the browser if it's included in the block list. And if it does, we block this request. This is a simple snippet. This will work in some extent, but we'll quickly realize that we have to be a bit smarter with comparing the URLs. First of all, matching every request against tens of thousands of URLs will be slow. This is a blocking operation, right? Like includes takes time. It will also block first-party requests. So if google.com was in your block list, you won't be able to visit that page. Also, the tracking URLs may look a little different every time. You know, query parameters change, subdomains, and so on. To block network requests effectively, we have to use some smart algorithms optimized for this problem. Fortunately, there are content blocking engines like Clicks Adblocker, which will do the work for us. This code snippet will download the latest content blocking rules from the CDN and will automatically use relevant browser APIs like Web Request. Well, congratulations. Now you have your first ads blocking engine. And the web can be fast, clean, and private again. Yeah, but sometimes when we block an ad, an empty space that was dedicated for showing that ad makes the web look bad or even broken. Also, sometimes annoying content comes as HTML, so cannot be blocked on a network layer, or at least not easily. To deal with such cases, web extensions use another capability called content script. Those could be CSS files or JavaScripts. Can be injected on every website, even before PageScript starts to load. Their role, in our case, will be to hide page elements. And yes, community lists provide those rules as well. To enable a content script, you add it to the manifest, specify on which websites it should match, and which script to load. So if you have Clicks Adblocker set up in the background, then with this simple code snippet, you will be benefiting from both network filtering and so-called cosmetic filtering. What happens here, you ask? Without going into much details, the content script, which loads in the context of the page, will get the domain of the page, send the information back to the background, asking for a specific set of CSS that should be applied for this particular website. And when the background will respond, it will inject the CSS to the page or mask individual elements based on the selectors that were provided by the background. Ta-da! Congrats! You now know how to create your very own ad blocker, and it will be blazing fast and simple. Just a few notes. Content scripts have access to website content that can even inject page scripts. Tracking prevention tools use this capability to monkey patch browser APIs like Canvas, cookies, or Fetch. They can replace the browser APIs directly. Wait, what? Yes, web extensions with wide host permissions know everything that you do in the browser. Any web extension can set data anywhere it likes. It is very easy. Take a look on this code snippet. This extension will report entire browser history to a tracking domain. This is very similar to how free flashlight apps steal user data on Android. We don't know, we use those tools, and they scavenge our data behind our backs. As web extensions developers, we have to be very careful with how we use those powerful APIs. And as of users, it all comes down to whom we are willing to trust. Sure, we can check the manifest version for permissions, but background scripts and content scripts are often obfuscated. We check the extension code. If it's open source, then this definitely adds transparency. We should look for browser vendor recommendations. You know, Mozilla does an excellent job by reviewing every single extension they recommend. And I tell you, they review it very thoroughly. They do an amazing job. Because there is a lot of amazing extensions that will benefit your life. And if you will choose the right ones, be sure to share your recommendations with others. Because otherwise, the people can fall into the trap of a poor choice and be a victim of a malicious extension. But let's get back to where we have started. Web is an amazing platform, and it changes very fast. We cannot allow surveillance capitalism to scavenge our data. With web extensions, we can protect our privacy, and we can do it because whenever a new threat comes online, web extension can learn about it and block it. As tracking evolves, so have our tools. This is a task that only web extensions can do, as browsers are unable to adapt that fast. So when a new tracker comes to existence, we have to track it and stop it. I work at Ghostery, where we gather information about tracking online and publish on the world's largest trackers database, Who Tracks Me. This website can answer questions like which website has most trackers or which trackers have the widest reach. Who Tracks Me is used by researchers, journalists, companies, and curious individuals to bring transparency to the web. Check it out. This is all that I have for you today. My name is Krzysztof Modras. At my work, I do track the trackers. Thank you all for listening. Enjoy your evening and the Warsaw.js. Cheers. And if we have questions, I'm happy to answer them. If only I will read them on the Slack, or maybe Barry will be able to transmit them on a call.
What's the process of verification of extension? Because I believe you have one, as I've checked in Ghostery.
Can you please repeat?
How much you need to provide to let Mozilla allow you to host your extension there? Thank you.
Awesome. Yeah, that's an excellent question. And I wish more add-ons will be going through the same process. Basically, what we have to do whenever we submit an add-on, we disclose entire source code, complete diff of all changes, together with all the changelog, like with the Git history. So basically, our extension is open source. So we compare two tags with each other. We send this to Mozilla. Together with tarball of the latest version, they try to reproduce the build locally to ensure that whatever we have delivered is exactly the same that they are reviewing, and that's what is being produced from the source. And then they even look deep into the dependencies that we bundle with our code. So this is a very thorough process. It takes multiple days or even weeks.
Krzysztof, we want to thank you very much. Apparently, your presentation was very clear, and people really understood what you were saying. I didn't, of course. I'll have to consult with you privately. Thanks again, and we'll see you next time. Thank you so much. Give him a hand, everybody.